lossy dielectric. Okay. So up to now, I think there is no confusion. So if any type of derivations are there, so you have to know the Phasor diagram, not diagram, Phasor equations. And I'm not writing all the equations of Maxwell's and all. What I told, only two is enough. Del cross ES is nothing but minus j omega mu into H of S, and your del cross HS is equals to sigma plus j omega mu, sorry, j omega epsilon into E of S. Now these two equations are enough, correct? So this is nothing but your Phasor form. These two equations, please remember. And again, I'm telling, if you forget also, what is the technique? You have to do, you have to remember the Maxwell's equation. Del cross ES is nothing but minus del B del T. At least this thing you can remember, correct? Lenz's law and all. So minus del B del T. So okay, del T is there. So it will be replaced by j omega. And D is there. Sorry, del B. B is nothing but mu into Hs. In this way, you can remember. That I'm telling. Now lossy means your sigma is not equals to 0 and its alpha is also not equals to 0. These two things you need to remember, correct? And your mu and epsilon, what is your mu and epsilon? Mu is equals to mu1 into epsilon naught, and mu naught, and epsilon is epsilon naught into epsilon naught. These two things you remember. I think I am recording now. Wait and see. Okay. So what I told in plane waves, during equation forming. So what I told, if you start from this equation, all the equation will be in the form of E of S or electric field. If you start from this equation, all the equation will be in the form of H of S. So let start from this one. And in the exam time, it is your choice. You will write in form of this one or this one. Now, if it is mentioned in the question paper that you write or derive the electric field equation or derive the magnetic field equation, then that technique I already told, correct? If it is electric field, then you have to start from this one. If it is magnetic field, you have to start from this one. Okay. Now, what are the techniques? First, you start from this one, then you have to do curl of curl. Already I told, this thing is quite common, correct? While doing the plane wave equation also, same thing you have to do. Here also, you have to do the same thing. So I will do very quickly. Del cross H of S, correct? Curl and curl is nothing but del into del dot ES minus del square ES. This thing also you have to remember, correct? And this is nothing but your 0. The gradient of divergence is 0. So this is nothing but minus j omega mu. Now curl of Hs. Can I write this one? Sigma plus j omega epsilon into E of S. Correct. So actually it is very simple. If you remember all these things, now you see one equation we have formed where all electric fields are there. Correct? Here also electric field, here also electric field. Correct? Now again I'm telling, if it is a 10 marks question, if they are asking to form one equation, don't start directly from this. Either your 10 marks you will not get. You don't expect that one. So first of all, you have to start with the original equation. Then you have to write the Phasor form. Otherwise, you will not get the full marks. From where this sigma and j omega, all these things are coming, you have to write that. At least one or two lines you write. Then you form all these things. So what we can write? Del square E of S is nothing but j omega mu sigma plus j omega epsilon into E of S. I hope all of you are following. Now, what we can write? Del squared E of S minus j omega mu sigma plus j omega epsilon into E of S equals to 0. Now, you just recall what I told in plane wave equations and all, correct? There also we have formed like del square V minus 1 by C square, something I told, V equals to 0 gradient and all. So this is about your plane wave. There also I told. So similarly, what we can write? This is actually the wave equation or Helmholtz equation. Already I told wave equation or Helmholtz equation or the wave equation. And this thing, whatever there inside, is nothing but your gamma square. Okay. So gamma square is nothing but j omega mu into sigma plus j omega epsilon. Okay. This is nothing but your gamma square. The gamma is nothing but your propagation constant. Already I told. So how to replace with a generalized equation? How to write is nothing but del square E of S minus gamma square E of S is equals to 0. Where your gamma square is nothing but this one. Okay. Now the twist is there. Now we will derive your alpha and beta. Correct? So some parameters we need to describe. Already I told what will be. Now here you observe. Let's say what I told, we have start from E equals to E naught e to the power minus alpha t. Please remember or recall cos of omega t minus beta z. And let's say this is ax cap. Just I'm telling. For an example, I'm telling. So if it follows lossy, here we are doing for lossy, correct? Where alpha is there, alpha attenuation is there, alpha is not equals to 0. So we need to derive all these things, alpha, beta, omega, everything we need to derive. So what we need to do? Alpha, beta, and omega, we need to find out from this equation. From this equation, we have to find out. How to do? Just I'm telling you. Now you follow everyone. So what I got? Del squared ES minus gamma squared ES is equals to 0. This is what we got. Now gamma squared is nothing but your j omega mu sigma plus j omega epsilon. And your gamma is your propagation constant, and this is nothing but a complex quantity where the real part is alpha and your imaginary part is beta. Okay, please follow what I am telling now. I will take another 30 minutes, so it will be very clear. Alpha and beta. Your alpha is nothing but your attenuation constant. Your beta is nothing but your propagation constant. Okay. Now here gamma square is there. Here gamma is there. Okay. We need to solve the equation. We have to solve the equation in terms of sigma, of epsilon, and all mu like that. You have to solve this equation. How to do? Now you see. It is not difficult, but you follow. Gamma is this one, correct? Now what will be your gamma square? It is nothing but alpha plus j beta whole square. Okay. So alpha plus j beta whole square means alpha square minus beta square plus 2j alpha beta. I think you know. Why minus beta square? J squared is nothing but minus 1. So this thing we know. Now what about your mod of gamma square? Mod of gamma square is nothing but alpha square plus beta square. Or we can write mod of gamma whole square. Both are same. Both are same. So this is nothing but your alpha square plus beta square. Now don't tell me how it is like that. Because this modulus is there, it is nothing but root over alpha square plus beta square. So square will be alpha square plus beta square. Right? Very simple. Okay. Now, what I can write, now you follow, your gamma square is this one. So you please multiply and make it as real and complex part. So what we can write, if you multiply with this one, it will come minus omega square mu into epsilon plus j omega mu into sigma. How? This thing you multiply, it will come and this j square will be minus 1. So this is your gamma square. Okay. I think it is clear. Now your gamma square is nothing but alpha square minus beta square plus this thing. This thing also we can write. All of you please follow. Alpha square minus beta square plus 2j alpha beta. Now you compare these two equations. You compare these two equations. This is your real part. This is your imaginary part, correct? And this is your real part and this is your imaginary part. Now can I write from these two equations? Very slowly I'm doing. If you have any query, you can ask. Alpha square minus beta square. Can I write this thing is nothing but omega square into mu into epsilon? Or we can write beta square minus alpha square is equals to omega square into mu into epsilon. Just compare the real part and imaginary part, correct? Similarly, what we can write is j will cancel. So we can write 2 alpha beta is nothing but omega mu into sigma. So this thing we can write. We now why we are doing all these things? We need to solve one equation so that we will get alpha and beta in terms of this thing. Okay. Up to this is clear, I think. If you have any confusion, you can ask. Now I'm going for the next part. One derivation will come. So
Sir, 1
be
minute previous slide.
tell me. Anyhow, I will give the recording, but you minutely follow. Huh? Should I repeat or just tell me? If it is clear,
Uh,
then tell me.
Clear, sir, clear.
Okay, I think all of you are following. Okay. Now, now look here. Beta square minus alpha square we got. Correct. Now, if I get one equation in form of beta square plus alpha square, which equation? This one. This one is. Here we are getting beta square minus alpha square. Here, alpha square plus beta square. So mod of gamma square we have to do. Correct. From there, we will get beta square plus alpha square. Then you sum up, it will come. Now you see what I'm doing. Mod of gamma square is nothing but your modulus of what? Mod of gamma square, already I told, it is nothing but gamma whole square. Both are same. Okay, you can do that one. Don't confuse, huh? And gamma is what? J omega mu sigma plus j omega epsilon. I think you know this whole square. Correct? This whole square means what it will come? It will come omega square into mu square into again omega square epsilon square plus sigma square. Now you do, this thing will come. Okay, I think some root also there. Root over is there. Root over is there. Because j is there, modulus is there. Okay. So finally, you will get like, okay, what is gamma square? This is nothing but alpha square plus beta square. So this will be equals to square root means omega into mu. Then this will come sigma square plus omega square into epsilon square. So this thing will come. All of you practice in your home also. You can get that one. So modulus means this squared, this thing will come, and finally you will get all this. Anyhow, you can follow from here also. So mu omega into mu, yes, sigma plus j omega, correct. So this thing will go. So this thing will come. Now here what we are getting, beta square minus alpha square is this one. So you equate. Here we are getting minus alpha square plus beta square. We are getting here omega square mu into epsilon. Omega square mu into epsilon. Now what you have to do, you have to just sum up, correct? So this thing will cancel. So 2 beta square will come. This plus this, omega into mu, sigma square plus omega square, epsilon square, plus omega square into mu into epsilon. This thing will come. From there you will get beta. Now I am just writing the expression of the beta. I am not doing the steps. I will share you on Tuesday the notes. There the steps are there. So it is anyhow simple. So you follow that one. So beta you will get omega into square root of mu into epsilon by 2, 1 plus sigma by omega into epsilon whole square. This thing whole square is here. Some students are confused with this one, plus 1. Now this equation will come. Anyhow, this is very simple. You take that one, this is beta square, correct? And you do one square root. Here you see omega is there, here omega square is there. So here also omega square is there, correct? Now if you do common, if you take omega square into epsilon square as common, so what it will come? It will come omega into epsilon, correct? So omega in here, it will come again omega square. So this omega will come here. Okay. So anyhow, the steps are there. You see the notes. So this we will get. I'm not deriving the detailed steps. It will take too much time. You can follow in the notes. This, all the steps are different. So this will be your beta. And your alpha will be exactly same. Your expression will be exactly same. Only this plus 1 is there, there minus 1 is there. Okay. So if you remember one equation, another equation also you can easily remember. Okay. So 1 plus sigma by omega into epsilon whole square minus 1. Now one thing I am telling you, here second bracket is there. So why I am telling, why I am focusing all these things. Here students are confused with this plus 1, this root over and all these things. Correct. So 1 plus sigma by omega epsilon, this is whole square. When sigma square divided by omega square epsilon square. And this 1 plus this one, overall this is square root is there. Okay. So don't get confused. And this is plus 1, this is minus 1. Anyhow, you will get all these things. I'm not doing all this detailed derivation. You can easily do all. It is there in the notes. You can follow. Huh? Some conceptual analysis we will do. I think up to this is clear. Now, some parameters you need to derive. First one, if you got all this thing alpha and beta, next is intrinsic impedance. Intrinsic impedance. Intrinsic impedance is represented by eta is equals to root over this thing you need to remember, plus sigma plus j omega epsilon. Now, how to remember? Again, I'm telling. We know that gamma square is nothing but j omega mu sigma plus j omega epsilon, correct? We know this thing. Now, how to remember? Let's say this is your numerator and this one is your denominator. In this way, do you remember? There is no logic, but still I'm telling. From there, your intrinsic impedance is coming. So detailed derivations are not there, is out of scope. But for numerical analysis, this thing is required. Find the intrinsic impedance and all. So you remember in this way. Okay. If you remember gamma square, from there, this is will be your numerator, this will be your denominator. Okay. Now, another thing I can say, this is a complex number, correct? So what we can say, some magnitude will be there. You're followed by your angle theta in. Theta in will be your angle, or we can write in this way in polar form, e to the power j theta. So anyhow, both are correct. If you write this is mod of eta, mod of eta is nothing but you know how to get mod of eta, correct? On Tuesday, we will solve some problems. It will be very clear. So you do this complex number, mod means this will come, j will vanish and all, you know how to do. Now, what is the loss tangent and all? I will come with loss tangent. Now, next topic is the loss tangent. Loss tangent. Now, we are discussing on lossy medium. So, some loss will be there. Then the ratio of the magnitude of the conduction current density J to that of the displacement current density in lossy medium is called your loss tangent. What is the ratio? Conduction current divided by your displacement current. Now, what will be your conduction current? Now, you remember this equation, del cross HS is nothing but what I told, JS plus del D del T. I think all of you can recall these equations, correct? So, this JS is your conduction current and this del D del T is your displacement current. You please remember what I told about that equation of continuity, modified Maxwell's equations. Already I told conduction means this current is because of the wires and all resistance and all. That's why it is called conduction current. Displacement current means across the parallel plate capacitor, some junction is there. There some displacement current is there. You please recall that one. So this del T is this one. Okay. And GS is what? Sigma into ES. And your del T is nothing but J omega epsilon into ES. Correct? So what we can write? And obviously this will be your modulus. Anyhow, loss tangent is your absolute value. So what we can write? Sigma into ES divided by J omega epsilon into ES. Minutely follow, modulus is there. So this two will cancel. So finally we'll get sigma by omega into epsilon. This is represented by tan of theta L. Again, I'm telling tan of theta L. Now, all of you please follow. This theta L and this theta N is different. Again, I'm telling students are confused with these two theta. Intrinsic impedance phase is represented by your theta N. Loss tangent means how much loss is there. That is represented by theta L. Both are not same. Okay, again I'm telling both are not same. There is a relation. I will come. What is the relation between theta L and theta N? There is a relation. So tan theta L is this one. So what will be your theta L? Is nothing but tan inverse sigma divided by omega into epsilon. These all are very important for your numericals. One problem will come. Calculate the loss tangent and all. So you have to remember this equation. Before that, I told you how to remember, correct? Js by Jd. In this way, you remember. Otherwise, it's difficult to remember all these things. Js and Jd, sigma into Es, J omega epsilon into Es, and your absolute value will come. This theta L is called loss angle. What it is called? Loss of angle. Okay. This theta L is called loss angle. Tan theta L is called loss tangent. Now, what is the meaning of this one? Now, what I told, this loss angle or loss tangent determines how much lossy or how much lossless or how much perfect your medium is. Your medium is said to be very good if it is lossless or perfect dielectric, if tan theta is very small. Okay. So what I told, I'm writing here, if tan theta L is very negligible, very small value. So what I told, it is a very good conductor. Sorry, it will be lossless. It will be lossless. Now, already you can see here, all of you please follow. Lossless, what I told, what are the conditions? Sigma is very, very less than omega into epsilon. Now you see this equation. This equation is what? Sigma is very, very less than omega into epsilon. So this angle will be very less. Yes or no? Now look at this equation. Good conductors, all of you please follow. Good conductor is what? Sigma is very, very greater than omega into epsilon. So your loss angle will be what? If tan theta L almost very, very high, so it will be your good conductor. Correct? There is no magic in writing and all. I think all of you, if you follow, why? Because sigma is very, very greater than omega into epsilon. What I told, conductivity is very high. So conductivity is very high for good conductor. Your loss angle will be very high. It doesn't mean it is lossy. It is a good conductor condition. Don't confuse between these two. Correct? So theta L actually determines how lossy a medium is. But for good conductor, your tan theta, that value will be very high because sigma is very, very high. If it is lossless, then tan theta, that value or loss tangent will be very less. Up to this is clear or not? Tell me. One by one, we are approaching. Look here. Analogy of loss tangent, what I told, tan of theta L is nothing but sigma by omega into epsilon, I told. Correct? This is for lossy medium. Always remember, this is for lossy medium. Okay. Now for lossless, what is the condition? For lossless, we told sigma is equals to 0. So your tan theta L is equals to 0. Or what implies your theta L, tan theta L is equals to 0 means your theta L is equals to 0 degree. Now for good conductor, what I told, if it is good conductor, your sigma is very, very high. Correct? So what it implies, tan theta L is very high, is approaching to infinity. Correct? Infinity means your theta L will be 90 degree. So this thing you remember. Why I'm telling? If in the problem, in the question paper, if you see your loss tangent is given 90 degree, so you can directly relate it is a good conductor. If it is 0 degree, it is lossless. Correct? And these equations you will use for lossy medium. Now, what is the relation between your theta n and theta L? This thing I am writing in big letters. You see, twice into theta n is equals to your theta L. Please remember, this theta n is what? This theta n is the phase difference. This theta n is the phase difference between your electric field and magnetic field. Okay, and this is your loss tangent or loss angle. So twice into theta n is equals to theta L. These two are different. Don't confuse. Okay. So this is the relation. This thing I need to tell. Now, what I need to say, I think all things are over. Alpha, beta. Okay, one small things are there. Yeah. You see, for good conductor, if theta L is 90 degree, so your theta n will be 45 degree, correct? You see, in this equation, if theta L is 90 degree, your theta n will be 45 degree. This thing you remember. This is for good conductor. Now one thing I will say, and okay, after this is over. Hmm. What is your skin depth? What is your skin depth? What is called skin depth? Skin depth means the distance. The skin depth is nothing but the distance when the wave amplitude decreases by a factor of 1 by E, or approximately 37 degree. It's called skin depth or penetration depth. Already I told, if the medium is lossy, so then what will happen? This thing will happen. Correct? If it is, let's say, Z direction, and this is your X direction, this will be your maximum amplitude. What I told, it will reduce. It will reduce, correct? So because of your alpha. If alpha is 0, then oscillations will be same. It's like a damped oscillations. In physics you have done. So your delta is 1 by alpha. How it is coming? E naught into e to the power minus alpha into delta is equals to E naught into 1 by E. Why? Because in the definition what I told, it will be 1 by E times. So 1 by E is, that value is coming 0.368. So your skin depth will be, if this value is 0.368, so your delta will be coming, this will be your skin depth up to this distance. So what is the meaning? Up to this distance, 36.8% or 37 degree, your amplitude is decreasing. Okay.
So
So,
can you once again tell what is skin depth?
so skin depth is what I told, the distance after what your wave amplitude, you look, this is your wave amplitude E naught, correct? Your wave amplitude decreases by 37 degree, or what we can say 0.368. Why it is coming? Because if you compare this equation, what it will come? Look here, E naught cancels. Alpha into delta is nothing but -1. So delta is coming 1 by alpha. Correct? So 1 by E times. So 1 by E times, if you in calculator, if you calculate, it will come 0.368, 1 by E. So 0.368 means, look here, this is your 100%. When I am telling you this is your E naught. Let's say this is 10 volt or 10. This amplitude is 10. Here it will come 0.368 into 10 means 3.68. So your amplitude will decrease to 3.68 after what distance? That will be your skin depth. Okay. I think you have understood now. Up to this distance. So this distance will be your skin depth. After which distance? Your amplitude will decrease to 36.8%. Okay. Uh, for good conductor, I will do later.